Hello all. In this video we are going to see midpoint subdivision algorithm. Midpoint subdivision algorithm is another line clipping algorithm. We've already seen what is two-dimensional clipping, what is point clipping, what is line clipping, and we have also seen one algorithm, that is Cohen-Sutherland algorithm for line clipping. Okay, so in Sutherland-Cohen line clipping algorithm, it requires the calculation of the intersection of the line with the clipping window edges. Okay, so you have an additional calculation involved, or a computation involved in midpoint in Cohen-Sutherland algorithm. So here what you are doing in midpoint subdivision algorithm is we are trying to decrease the amount of computation. Okay, so these calculations can be avoided by repetitively subdividing the line at its midpoint. Okay, so like this Cohen-Sutherland algorithm, what we do is initially the line is tested for visibility, that is whether it is completely inside or completely outside, or it is partially inside. So we are initially testing the inside outside test is performed first. So if the line is completely inside the clipping window, it is drawn. If it is completely outside, it is rejected, and if it is partially visible, then you are going to subdivide it into two equal parts. അതായത് we are going to find the midpoint of that line, and you are going to divide it into two lines, and then you check the visibility of each half. Okay, and this subdivision process is repeated until we get completely visible and completely invisible line segments. Okay, so this is basically midpoint subdivision algorithm. Okay, so if you see this figure, you will understand it more clearly. That is, in midpoint subdivision algorithm, first we are going to give region codes for each endpoints. Okay, so here you have P1, P2. If you see the figure A, you can see there is a line segment P1, P2, and the P1 is to the left of the clipping window, so the bit 1 should be set. So this it will have a code 0001, and P2 will have a code 1000 since it is on the top. Okay, so when you when you have an endpoint, you find the region codes. Then what you have to do, if it is if both the endpoints are having 0000, then it is completely inside visible, it is completely visible, or it is completely inside the clipping window, so it should be drawn. Here the region code is 0001 and 1000, so it is not inside the clipping window, it is outside the clipping window. So you have to find whether it is completely outside. So in order to find whether it is completely outside, what you do, you have to perform the AND operation. Okay, that is, these things are all similar to Cohen-Sutherland. Okay, we perform the AND operation on this, that is 1000 and 001 is performed, then you get 0000. So which means that if it is partially inside, if it is outside, then the AND operation, the result of AND operation will not be 0 0 0 0. So here it is partially inside the clipping window. So you can see this is partially inside the clipping window. Okay, so now what you have to do, if it is partially inside, then you have to find where it should be clipped. So here in midpoint subdivision algorithm, the difference is that here we are going to divide this line segment P1 P2 into equal halves, and you continue it until you get the visible part of this line segment. So here first we are going to divide this line segment P1 P2 into 2 points. That is, you find the midpoint P3 here. Here P3 is the midpoint, and you have divided it into 2 line segments P1 P3 and P3 P2. Okay, then what you do is you find whether this line segments are completely visible or completely that is, if it is completely inside or completely outside, again using the region codes. When you perform from that, you will understand that again P1 P3 is partially inside the clipping window. So what you do, you again divide it into two halves. That is, here you have P4. So this P1 P3 will be divided into P1 P4 and P4 P3. That is, the P4 is midpoint of P1 P3, and similarly P3 P1 P2 is also partially inside the clipping window. So you divide it into two halves, that is P3 P5 and P5 P2. Okay, so again you check what these line segment P1 P4 is inside, completely inside or completely outside. When you check this, you will find that this P1 P4 is completely outside, so you reject it. Then you check P4 P5 P4 P3, then that is partially inside. Again you have to subdivide it. You check P3 P5, it is completely inside. So you draw that line. Then P5 P2, that is completely outside, so you reject it. So here now you have rejected two parts P1 P4 and P5 P2. So that part is rejected, and now you have P4 P5 P4 P3 and P3 P5. Okay, again these are partially inside or partially outside. Again you will have to divide these lines into two halves. So you have divided this P3 P4 into two halves, that is P6 is the midpoint of P4 P3. So you get P4 P6 and P6 P3. You find that P6 P3 is completely inside, so you draw that line, and still P4 P6 is partially inside. You subdivide it, you find the this part P4 P7 is completely outside, so you reject it and you draw the remaining part. So you get the whole line segment that is visible inside the clipping window. So you get the line P7 P5, that is the line that should be visible inside the clipping window. So this is how you do midpoint subdivision algorithm. So the midpoint subdivision algorithm is given here. So you first read the two endpoints P1 x1 y1 and P2 x2 y2. Then second step, you read two corners, left top and right bottom of the window, say wx1 wy1 and wx2 wy2, that is the window borders. Then you assign codes, region codes for two endpoints using for the following steps. That is, initialize the code with the bit 0000, then set bit 1 if x less than wx1, set bit 2 if x greater than wx2, set bit 3 if y less than wy1, and set bit 4 if y greater than wy2. Then you check the visibility of the line. If the region codes for both endpoints are 0, 0, 0, 0, then the line is completely visible. Hence, draw the line and go to step 6, that is you stop. Then if region codes of the endpoints are not 0 and the logical ANDing of them is also non-zero, then the line is completely invisible. So reject the line and go stop. Otherwise, if the region codes of the two endpoints do not satisfy the conditions in 4a and 4b, then the line is partially visible. So, in step 5, you divide the partially visible line segment into equal parts and repeat step 3 through step 5 for both subdivided line segments until you get completely visible and completely invisible line segments, and you stop. That is the midpoint subdivision algorithm. I have given an example here. You can go through it. I will give the notes. With that, you can understand midpoint subdivision algorithm. Thank you.